Welcome back, Patriots. Let's go ahead and get started on Lesson 2 in Unit 4. Now, we're going to take a break out of doing any sort of high-level math today. We're not going to be doing hardly any, add, subtracting, multiplying, dividing, maybe a little bit of dividing, but we're going to take a break from all of that and focus just on what math means. So, think about back when you were like a little toddler. When you first started learning how to count, the very first math you were ever exposed to was whenever you started counting on your fingers and you started going 1, 2, 3. And really, when you think about it, there's no point to any of that. What is the point to a toddler adding? The only reason that they do it, the only reason that they count is because you give them a high five, you give them a fist bump, you give them praise, and they want to make you happy. That's the only reason that they do it. The numbers themselves don't actually mean anything until the moment that it does. Think about the little 3 or 4 year old who's in the kitchen and really wants to help mama make a sandwich. And she looks over and she says, "Okay, can you get me 2 pieces of bread?" And then that toddler walks over and grabs the pieces of bread and does to the bread what they did with their fingers before. They used to go 1, 2. Now they're picking out of the loaf of bread and they pick up 1 loaf or 1 piece, then 2 piece. And now those numbers have meaning. You see, numbers are always completely useless until they're applied to something. And that's what we're going to be doing today, is talking about these graphs and the different parts of the graphs and what they mean in actual situations. Because we can have all these graphs on a page, but those are useless unless we actually apply them to something. So that's what we're going to be focusing on today, is what does an intercept actually mean in the context of the problem? What does the slope mean in the context of the situation? Because context is absolutely everything when it comes to applying math problems. So the first thing we want to look at is number 1, what does the title of the graph tell us? Well, if I look at this, I've got my salon profits. Okay, so I'm just going to go ahead and write that in. Salon profits. And that tells me a few things. Number 1, a salon. We're most likely talking about a hairdresser or someone who's working in a beauty salon. Profits, well, that's the amount of money that someone makes after expenses. Because whenever I talk about the profit of something, if I spend $1 on a candy bar and I go back and sell it for $1.50, my profit is actually just 50 cents, because that's how much money I made over what I spent. Okay, so we're going to have some negative costs in here maybe, and we'll see that more as we go. Okay, what is on the x-axis? And in this case, I've got to look at the axis label. I'm going to look over here, and I can see that my x-axis is talking about number of haircuts. So sure enough, this person working at the salon is going to be giving haircuts, and we can see how many haircuts they've given across the x-axis as I go horizontally. All right, next question. What is on the y-axis? Well, my y-axis, it looks like I have profit. And if it ever gives me units, I want to make sure that I pay attention to that. So this profits is in dollars. It's very important because, again, context is important. We want to know we're talking about dollars and not cents. Okay, what is the x-intercept? The x-intercept, of course, is the place that crosses the y-axis. That's where y is 0. And I can trace this along until I get to y equals 0, which happens right here. So I've got the coordinates 12, 0. And now remember, we've always got to be thinking about what does each of these numbers mean. In the x position, that's 12 haircuts. In the y position, that's $0. So what does that mean? That means that if she gives 12 haircuts, then the profit is $0. Now, a $0 profit, that's also considered the break-even point. She would have to cut 12 heads of hair in order to make up for the money that she lost. Okay, what does the y-intercept mean? Well, if I look at the y-intercept, that y-intercept happens when x equals 0. So if I trace along here to where x equals 0, it's right there at 200. So it's at negative 200. Now, what does that mean? Let's see. X0 is haircuts. So if no haircuts are done, then $200, negative $200, then I guess she loses $200. And at first, people start questioning, what in the world does that mean? How can she lose $200? Well, think of the way that some salons work. They have a whole bunch of chairs set up or a whole bunch of booths set up, and each hairdresser has to pay a rental fee in order to get their chair for that month. So in this particular case, it might be that she's got to pay a $200 rental fee to use her chair that month. That way, the salon owner makes money regardless of if any haircuts actually happen or not. So then she pays $200 at the beginning of the month for her booth rental. And then from that point on, every single haircut that she makes is going to gain her money to the point where at $12 or at 12 haircuts, then she gets the break even point. Okay, so now it's not on here, but I also want to talk about what does the slope mean. Okay, now if you remember, slope is going to be the change in Y divided by the change in X, which in this particular case, the Y is profit, and the X is haircuts. So the change in profits divided by the change in haircuts. Well, if I look at that, I can take these 2 points and I can figure out what my delta Y is. Okay, that means that from negative 200 to 0, that is a $200 rise in profit. My horizontal goes from 0 to 12. That's a change of 12 haircuts from 0 to 12. And then I can reduce that. Let me grab my calculator. $200 divided by 12 means that we are doing, where's my purple? 16.67 divided by 1 over 1. So what that means is, again, profits per haircut, she's making $16.67 per haircut. So here the slope is how much money she makes per haircut. So again, the point is that on all these, the X-intercept, the Y-intercept, and even the slope has a meaning. Now, that would be important if our hairdresser is trying to decide how she wants to make more profits, because maybe she would want to make her line look more like this. Because if that's happening with a steeper slope, that means she's making more money per haircut, which means she's making more money over time, which would be very helpful to her business. So, let's go ahead and move on to our next one. This time we don't have a graph, we've got a table. So first off, what is the title of our table? Well, I can see that the title of my table is the cafeteria account balance. Okay. And now what is the title for my X column? My X column looks like it's number of weeks. What is the title for my Y column? My Y column here is remaining balance. Okay. So again, let's talk about scenario context here. It looks like cafeteria account balance. Oh, that's sort of like when your parents drop money on your account in Skyward for the cafeteria. You know, they start off in this particular case, they start off giving you $100 and they put in the account. And over time, you're spending money in the cafeteria. And so your account balance goes down every single time. Of course, that's considering you don't have free and reduced lunch. So let's see, what is the X-intercept? Remember, X-intercept happens whenever Y is 0. So if I got my Y column over here, Y equals 0 happens there. So my X-intercept happens at 4, 0. Now, what does that mean? Well, at 4 weeks, we have $0. Well, to have $0, that means the money has run out. So that means, I guess, we're out of money at 4 weeks. Okay. What about our Y-intercept? Let's see. The Y-intercept happens when X is 0. X is 0 right here. And that is $100. So 0, 100. And now we got to talk about what the idea of zero time means. This is a concept you're going to come up with over and over and over again. And zero time really starts to start sounding a little bit crazy when we first start thinking about it, because how can there be zero time? Well, let's talk about your age. Let's actually talk about something that I think you all will appreciate. Let's talk about age of a child and their height. So right now, all of you guys are sitting here right around 13, 14, 15 years old. I'm going to put 14. And let's just say a normal average height for somebody that age. I guess some of y'all are taller, some of y'all are shorter. But, right there in the middle would be somewhere around 5 foot, 5 inches. Okay. Now, we know that baby was not born at 5 foot, 5 inches. We know that baby was born really, really small, usually somewhere around 16 to 23 inches, somewhere in there. Don't quote me on that because my knowledge of baby heights is not the best, but somewhere down there. And they start off growing, and then it kind of tapers off, and they have another growth spurt, then tapers off, and it grows up, and then you kind of just stay flat for a while until you get really old, and then you get osteoporosis, and it goes down a little bit. Okay, but my point is that over time, your age gets taller, or your height gets taller. Now, let's jump back and let's say we go to age 7. At age 7, your height is somewhere in here, maybe somewhere around, I don't know, I'm making these numbers up as I go, maybe somewhere around 4 foot 3 inches. If I back that up to age 2, maybe you were somewhere around 3 foot tall. What about right here, the X-intercept? What would that represent whenever time is 0? Well, for time to be 0, the 0 age for a person's life, there's only one instant when that happens. That is the moment that they are born. Okay? See, 0 time always refers to the beginning of something. So if you're talking about a race, the 0 second is the moment that the gun goes off to start the race. If you're talking about age, it's the moment of birth. If you're talking about a chicken, 0 age is the moment they hatch. Okay, 0 time is always the moment at which something begins. That's why the X-intercept is sometimes referred to as the starting point, because that's the place that we start. Okay, so back over to our example over here. What does the X-intercept mean? 0, 100. Well, that would mean at the beginning of the semester, beginning of the week, we don't know exactly what this is, but at the beginning, they had $100. So I'll just call it the semester. At the beginning of the semester, the account has $100. Okay, and also, just like before, I want to talk about slope as well. We're going to talk about slope quite a bit on the next page. Okay. Slope is always change in y, which in this case is balance, divided by change in x, which is weeks. So that looks like that's going to be how much the balance is changing per week. So balance per week is what our slope is going to tell us. So if I look at the numbers there, I can do my delta y and delta x just like I did before on a table. To get from 100 to 75, I've got to subtract 25. To get from 0 to 1, I'm going to add 1. So, and that balance is in dollars. So it looks like we can tell that this person is spending, well, negative 25 over 1. I didn't change anything there. It doesn't reduce. $25 in 1 week. So they're spending $25 per week. We average that out. That's $5 per day. And then I guess understanding that a family could have a conversation about, is that a reasonable amount for a child to be spending on lunch? In my mind, well, I know that the here at Eastview, teachers have to pay $3.75 a day. Students actually get it at an even more reduced rate. I don't know what y'all's is. It's somewhere around $1.50 to $2, or even you don't have to pay for it at all. But if my kid who's supposed to be paying $1.50 for lunch is spending $5 a day, we're going to be having a conversation, because that means they're getting 2 lunches, maybe 3, and that's a problem. But my point is, again, the slope, the Y-intercept, the X-intercept can give you insight into what's actually going on. Okay, let's talk about this one. oil in an oil tank. Now, there's not a lot of questions on this, so we're going to talk about what does x-intercept, y-intercept, and slope mean for every single one of these. Now, I don't have an x-intercept because my x-axis, I never actually touch it. My y-intercept here is at the point 0, and since there's no scale on there, I assume each line is 1, so it's at 0, 2. But then again, what does this even mean? Well, my title says we've got oil in an oil tank. So that's how much oil is in there. And it looks like we've got number of minutes. So we're looking at how much oil there is over time. And over here on my Y, I've got, amount of oil in gallons. So as this rises to the right, time is going up and oil is going up, which it looks like they're putting oil into this tank because the oil level is getting higher and higher over time. We're filling up this tank. Okay, so what does the y-intercept mean? 0, 2? Well, at the beginning, I guess when we started filling it up, there were 2 gallons in the tank. Okay, again, there's no y-intercept here, so we can talk about slope. And this is going to be change in y is gallons over change in minutes. So that's, I guess, the rate at which we're filling the tank over time, how many gallons we're putting in per minute. So if I went through and calculated that, find 2 points, I've got the y-intercept there. Yep, looks like we got this point right here. So my delta Y, my delta gallons is 1, 2, 3, 4 over delta minutes. Now I got to look at my scale here. That's 10. So if I reduce that, by the way, that's gallons in minutes. Reduce that, I've got 2 gallons every 5 minutes. And so it looks like we're putting in, 2 gallons every 5 minutes, a gallon, 1 gallon every 2.5 minutes. So kind of a slow fill going on here, but anyway, that's what this stuff means. Okay, I don't like that one. I'm actually going to skip that one just for time's sake. I like Donna's yard service example. Okay, so let's look at what we got here. Donna's yard service, so Donna is doing some sort of yard work. Her X, remember X is here and Y is here. X is hours worked and Y is the amount that she charges for her services. So it looks like we're talking about here, I guess more hours that she works means that you get charged more, which again makes sense. Okay, let's talk about our slope. That's going to be our easiest one to do first. Okay. That is delta Y, so that's the amount of the change in the charge divided by the change in hours. So, and this one looks like this one's always given in, I guess I should do that in blue. This one is always in dollars. So, let's see how much we're actually changing things here. From 11 to 17 is 6. We're adding 6. Oh, charge goes on top. So $6. The change in hours, we're going to be adding 1 there. So that's 1 hour. So that's already reduced. It looks like she's charging $6 per hour. Now, I guess we could have a conversation there about, is Donna charging enough? Let's see, if she's only charging $6 per hour, is that worth it for her to be doing yard work? And again, I'd say context really matters here, because if Donna is someone who does this as a professional job, like this is what she's doing as I don't know, a 25, 26-year-old who's running a business, is $6 an hour worth it for her to charge? I would honestly probably say no. But let's flip it around, and what if Donna is a 10-year-old who's going out and trying to clean out flower beds to try and make some extra money? In that situation, is $6 an hour enough? Well, actually that might be just about right. So, all right, now let's talk about the x-intercept. Okay, actually the y-intercept. Now, y-intercept happens where x is 0, and there's not a 0 anywhere on this chart. but we could find it. Because as I notice this, I'm jumping back by 1 as I go from right to left. So if I gave myself another slot on this table, I could jump back another 1 and get to 0. I could also jump back this way and see that I'm going 6 every time. So if I jump back 6 again, then that would be $5. Okay? So the y-intercept is the 0.05, and what means that for 0, x is hours, for 0 hours she charges $5. Now, in this case, we got to realize that we wouldn't do no work and charge $5. That's actually her starting fee. She starts at $5. Basically, she charges $5 just to begin working on your yard. So let's go over here to this one. Now, let's talk about our y-intercept first. Our y-intercept is at the 0.04. And in order to know what those mean, we got to look at our labels. So X is weight in pounds and length of spring. So as I'm adding weight, the spring gets less. What that sounds like to me is one of these like kind of physics experiments you do where you've got a platform of some kind, and then you've got this spring attached to it. And then off of that spring, you handle or hang some sort of weight. So the more weight that's on it, that spring gets longer if you have a larger weight on there. That's what that sounds like to me. So as we add more weight, the spring is going to lengthen out. Okay, so if I have 0 weight, the spring is 4 inches. Well, that sounds like that is the natural length of the spring is 4 inches. And when I say natural weight, I mean without putting any weight on it to stretch it out. Okay, let's also look at our slope here, because there is no y or x-intercept, so we don't have to worry about our slope. We don't have to worry about our x-intercept. Okay, so that is going to be the change in the length divided by the change in the weight. All right, let's see what we can come up with here. I already drew all over that, so I'm going to do it over here on the side. Change in length from 6.4 to 7.2. Let's see, I can do that with subtraction. 7.2 minus 6.4 is 0.8 inches. And then from 1.5 to 2, that is 0.5 pounds. Okay, now I need to reduce that fraction. And honestly, when you have decimals like this, the easiest way, I said reduce, I'm sorry, I meant simplify. Easiest way to simplify that fraction is to multiply by 10 to get rid of that, those decimals. So we got 5 pounds for every 8 inches, which means every 5 pounds I add on, the spring is going to get 8 inches longer. So, all right, I know I didn't do all of these on the right-hand column. Honestly, we're already at 23 minutes. I don't want to push this too long. Here's my point on all this. Look at the context. Look at your labels. Slope, y-intercept, and x-intercept always have meaning. Anytime that there are labels, anytime that there are units, those have meaning and they help you interpret the context. Because what's going to happen is, as you get farther along in your science classes, your science teacher is going to start actually asking you to apply this to real-world scenarios where you do an experiment and you got to know how much the volume or the mass of a liquid is going to decrease over time in a chemical reaction. And all of a sudden, those graphs, the x-intercept, the y-intercept, and the slope, have meaning to the actual application. And remember, math is completely meaningless without an application behind it. We spend a lot of time talking about just the numbers in math classes. Well, in your science and engineering classes, you're going to actually learn how to apply those things. So that's it. The lesson is yours. You guys have a good day.